Okay, so let's just use that calculator to put that number 3 in here and answer the question, find the standard deviation. Well, the question already said find the sample standard deviation. So what I'm going to do is on my calculator go to STAT, hit enter, and then I don't like what I have in my L1, so I'm going to clear it. So arrow up, clear, enter. And then I am going to put that data in my L1. So the first is 23, enter, 13, enter, 4, enter, 8, enter, 9, enter. Please try to emphasize that whenever you enter any data, you have to go back and eyeball it because people make mistakes. You can just maybe not know that you put one number on the horizontal line, so that you now have 2,313 instead of
Right.
20, instead of 23 and 13. So what we can do is eyeball, go back and check and see if you enter the data very well. Then if you want to sort in ascending order, you go ahead, but we don't need to sort in ascending order because I'm not looking for the mode. I'm not doing a stem and leaf plot. So there is no need to sort in ascending order. So what I'm going to do is I'll just go to STAT again, arrow to calc, and do one variable start. Arrow to calc and do one variable start. So if I hit enter, then the question says find the sample variance and standard deviation. So what we do need to remember, okay, so I'm going to calculate. First of all, my list is an L1, so that's why I have list L1 here. I don't have frequency because it's not a group data, so I will not put anything in frequency. So I'll arrow down and calculate. All right, so now that I have calculated it, if I'm told to find the mean, this is the mean. And this is a sample, so this is sample mean, but I'm not told to calculate the mean. But I'm told to calculate the sample standard deviation. The sample standard deviation is S of X, this one. So this is sample standard deviation. So I'm going to draw sample standard deviation is this. Sample variance is this. So these are the statistics that I'm told to find. Why are they statistics? Because they belong to sample. So sample characteristics are statistics. Population characteristics are parameters. So if the question had told me to find the population standard deviation and variance, then I would have selected this for if it is a population. This one shows you population standard deviation. When you square it, it gets population variance, sigma squared. All right, so now I am going to let me clear this. Listen, they need to fix it. It's not, it doesn't clean very well. Anyway, so we are now going to calculate. So let me get my calculator again. I already calculated. So I have sample standard deviation, and it has 7 digits, maybe 9 digits. 7.231873993. But anyway, I don't need all the decimal points, but I cannot just start truncating. So the next thing I want to do is go to my VVARS. If I go to VARS, and I'll see VAR statistic. VAR statistics gives me that the standard deviation of a sample is number 3. If I'm looking for that of a population, it's number 4. So I will choose 3. So it pulls out the sign for sample standard deviation. Then if I hit enter, it gives me all those 9 decimal points. The reason why I want all 9 decimal points is because I'm going to square it. So I'm going to square it. Now that I squared it, I have variance. So, and I'm told to leave my answer to 1 decimal point. So the variance is 52.3. The standard deviation is 7.2. So I come over here and put 7.2. 7.2 is the sample standard deviation. And then 52.3 is the sample variance. 52.3. So that's my answer. Okay, the students always do it right, but they forget that S is for sample, sigma is for population. That's all. It's not even a big deal. So I'm recording it now. So you think you can do it now, right?
Yes.
Hello, Carrie?
Yes.
Okay, Terry. Okay. All right. So now let's go to normal distribution. So let's go to normal distribution. So now I am pulling up normal distribution, the worksheet we worked on yesterday. Okay, so, and you already know how to do this, and you showed the kids how to do this, right? You showed them how to do it.
We
Yes.
covered that a little bit on Monday, but we did not do any problems on it today.
Okay. Well, let's do it again. So, with calculator, I'm going to do number 3, and I'll do number 5. So, whenever the question says find the area in exercise 3 and 8, find the indicated area under the standard normal curve. So this is already standardized using z-score. It's already standardized using z-score. All right, so now I know that I should draw a standard normal curve. So I'm going to draw a standard normal curve I will use to answer that question. The mean of a standard normal curve divides the normal curve into 2 equal parts. And the total area under the normal curve is 100%. Therefore, the mean, mu, divides this normal curve into 50% and 50%. And if I decide to write it in decimal, I have 0.5. Okay, so now I can use my calculator. Let me see if I can use my whiteboard, because for some reasons this doesn't clean very well. So now the question in that number says area between 0 and 1.28. So this is number 3. I'm looking for area between 0 and 1.28. So this is 0 and this is 1.28. And then I'm told to find area. All right, so I'm going to use my calculator, and the argument is normal C, D, F, normal cumulative density function, smaller number, 0 is smaller than 1.28. Then mean is 0, standard deviation is 1. Actually, the argument is normal CDF, lower bound, upper bound, mean, and standard deviation. All right, so I put the numbers in: lower bound, upper bound, mean, standard deviation. So now I'm going to pull my calculator up, and then I will look for normal CDF. Okay, so second distribution, the normal CDF is number 2. And the question says find the area between 0 and 1. I mean 0 and 1.28. So my lower bound is 0. My upper bound is 1.28. The mean of a standard normal is 0. Standard deviation is 1. Best. See, now my calculator is asking me, is what you entered correct? Is that what you want to find? Yes. So then I'm going to hit enter. So area under the normal curve is 0.3997 to 4 decimal points. But they can actually ask me to put my answer to another. Let me see how many decimal points. Okay, it didn't actually tell me on the, okay. But it says hint, draw a normal curve. Okay. So let's decide to put the answer to 3 decimal places. So our answer to 3 decimal places is point. You see, it's going to give me 0.4 because if I round 7 up, it makes 9. So I'm going to, it's going to be 0.4. So this total area from here to here is 0.4. If I'm told to leave my answer in percent, then it is 40%. Area under the normal curve is the same as probability. It is the same as relative frequency. And you could be told to leave your relative frequency to percent. Okay, so that is area between. So this is area between. Area between. What if I'm told to find area to the right? So let's look for a question that says area to the right. I'm going to pull down and I'm look for area to the right. So question number 5 says find the area to the right. So I will pull up my, and it says find the area to the right of 2.4 in a standard normal. Why do I know it's a standard normal? Because they gave me Z. So I will pull my calculator up and I'll write the argument. I have already pulled my calculator up. That's why I like to use this one. So I can clean this part now because I don't need them anymore. Let me clean this part. So I'm going to clean the, this is better. It cleans faster than my PDF. All right, so now I am about to answer the question on area to the right. And right of what? So to the right of 2.4. All right, so let's to the right of 2.4. So I go back to my board. The first thing you want to do is draw a normal curve. Question number 5. For every question on normal distribution, draw a normal curve. So area to the right. All right. And then I want to find the area of the area to the right of 2.4. By the way, the mean is always 0. So mean is 0. So I know the line of symmetry is 0. And 2.4 is positive. Therefore, z equal to 2.4. Yeah, 2.4 is on the right-hand side of the main. Right-hand side of the main. All right, but see, the very important thing is that the normal curve goes to positive infinity and goes to negative infinity on the left. But our calculator does not understand infinity. So in place of infinity, we put in 1 e to the power 99. I hope you know that this is the same as maybe one. It's just scientific notation. But we don't, anyway, we don't need to go into details. So instead of typing in infinity in your calculator, you type in 1 e to the power 99. So I'm going to write the argument. So now I'm going to write the argument. The argument, normal CDF, lower bound. The lower bound is 2.4. The upper bound is infinity, positive infinity. The upper bound is positive infinity. And this is how I'm going to write it in my argument. The mean is 0, the standard deviation is 1. Okay. All right, so it is time for me to put it in my calculator like we did before the other day. So I'm going to put my calculator up. It's already up. So I hit enter and I'm going to clear. Now I'll go to normal CDF. How do I get there? Remember, it is second. Of course, you know how to do this already. Very good. So 2. Select 2. An area to the right. Remember that the smaller number is that comes first. That's 2.4. So 2.4 is the smaller number, lower bound. Then upper bound is positive infinity. So let's type it in again. I think you already know how to do that, but let's type it in. So 1, where do I find E? E is under comma. Second to power 99. So I have just told my calculator to find the area to the right of 2.4. Find the area to the right of a standard normal curve from 2.4 and above. So I tell my calculator that this is a standard normal curve, so because mean is 0, standard deviation is 1. So I passed. So asking me, is that what you want? Yes. Hit enter, and I get an answer. All right. Let's do area to the left. And what we do after we do area to the left, we read the chart. We get a chart and read the chart. Okay, so area to the left. I'm going to clean this one because I don't need it anymore. So I'm going to get a number that says find the area to the left. All right, so I'm going to get to that question again. And area to the left is what I'm looking for now. Number 6 says find the area to the left. So when I'm looking for area to the left, I have to draw a normal curve again, showing area to the left. So I'm going to type it in. So I type it in my calculator. So area to the left is what I'm drawing. Oh my goodness. My normal curve needs to look better. All right. Draw a normal curve. Okay. Much better. So this is the mean. Mean is equal to 0. All right, so now it is to the left of, let me see what it, negative 0.46. Because it is negative, it is actually below the mean. It is negative, so it's below the mean. So I am going to go to my whiteboard, and I'm looking for area from here to negative infinity. So I have negative showing that this z-score is below the mean, 0.46. Let me go back and make sure that okay, 0.46. Okay, that is 0.46 area to the left. Okay, so as soon as I get that, I am going to show that negative infinity means negative 1e to power 99. Okay, now write the argument. Normal CDF, negative 1e to power 99. Then the upper bound, even though it is negative, is still greater than negative infinity. So negative 0.46. The mean is 0. The standard deviation is 1. All right, so now I'm about to calculate. So what I am going to calculate now, I am going to type this in my calculator. So go to second distribution, select number 2. Lower bound is negative 1e to power 99. I get the e above comma because negative infinity is lower than negative 0.46. So I have negative 0.46. All right, and then I am using a normal curve that is standardized. So mean is 0, standard deviation is 1. So it's going to show me what I put in. Is it correct? Yes, that's what I want to find. So I am going to hit enter. And it tells me that area to the left is 0.32. That area is 0.3227 to 4 decimal places. But I can be told to leave my answer to 3 decimal places. So my answer will be 0.323. I think it's better now, right? Yes? You, Carrie, are we together?